This is Engage New York, Module 2, Lesson 6. Read the objective while I read it out loud. I can connect area models and the distributive property, remember, distributive property to partial products of the standard algorithm with renaming. So when you multiply in little pieces and then you add them up, right? So you multiply, and you get a partial product, and then you add them up to get the answer. All right? So let's go ahead and get started. So multiply mentally using a pattern sheet. Go to the cover sheet of the problem set, you guys. Let's see. I'm going to give you 1 minute to multiply mentally or add or subtract mentally and see how you do. So I'm going to give you 1 minute, pencils up. And hold on. 1 minute, stopwatch timer. Okay, ready? Go. All right. So 5 times 100, 500. Then 500 minus 5, well, that would be 495. Then think of 5 times 100 minus 5, which would be 495. Then we have 300. Then 300 minus 3, 297. 3 times 99 turns out is 297. Then 200. Then 200 minus 2, 198. Do you see a pattern here? 200. Then we have 2 times 99, 198. So look the way this could be solved. Then we have 600. 600 minus 6, 594. Well, look at this. 6 times 99, 594. Then we have 400. Then we have 396, and if you just multiply this by 100 and then subtracted 4, 396. Then we have 700. Then we have 693 because if we say, oh, well, that's really 700, take away 7. 900. Then we have 9 times 99. Well, it'd be 900, right? Subtract 9, which would be 891. Then we have 800. 8 times 99, that would be really multiplying by 100 and taking 8 away, which would be 792. Then we have 500. Then we have 5,000. How are you guys doing? So being nimble with your thinking is our big idea here. So 5,000 minus 50 would be 4,950. Then, oh my gosh, it's like 50 times 99, 4,950. Then we have 8,000. Then we have, this is like 8,000 or 8,000, and you're going to take 80 away. So it's 7,920. Then we have 6,000. Then we have 5,940 because we're going to take 60 away from here. Then we have 1,100. And then we're going to have 1,100 minus 11, which is 1,089. And 11 times 99 would be 1,089. So I'm going to stop here and I'm going to allow you to finish this up on with your homework. So I want you to continue to practice being nimble with your thinking forwards and backwards and multiplying and subtracting or adding. That is going back to one of our big ideas in 5th grade is being able to round to a number that's easy to multiply or add to, and then being able to think backwards and subtract back. All right, so the rest of our fluency is to multiply by multiples of 100 really quick. Then I want you to multiply using the area model. So yes, I want you to draw. Each one has to have an area model. Then your application problem. Scientists are creating a material that may replace damaged cartilage in human joints. That would be amazing. This hydrogel, can stretch to 21 times its original length. Whoa. If a strip of hydrogel measures 3.2 centimeters, what would its length be when stretched to its capacity? So I want you to think that out. I want you to go ahead and try it so that when we come back, you can see where you were able to start and how far you were able to get. If you don't start it, then you don't know what your abilities are. So I want you to make sure to go ahead. I'm going to give you about 5 minutes to complete those, and then we'll come back to debrief. All right, let's go ahead and get started. So 8,400, 93,600, 462,800. Then using the area models. So 43 times 2 plus 2 plus 10 is really 12. So 43 times 2 is 86. 43 times 10 is 430. Adding them up, 516. Then we have 243 times 2 plus 10 is 12. So breaking it up into smaller pieces, then adding them up, 2,916. Then 312 times 3 plus 20 is 23. So breaking it up into bite-sized pieces, adding it up, 7,176. Give me a thumbs up and let me know how you did. All right, so 3.2 centimeters times 21 original length times its 21 times its original length. So we could change this. There's two different ways to do it. Standard algorithm and using the area model. 32 tenths times 21 is 32 times 1 plus 20 is 32, and 640 is 640 plus 32 is 672 tenths, and then we have to move because we moved that decimal out of the way. We got to move it back. 67.2 centimeters. You could also use standard algorithm, 3.2 times 21. We could get rid of that decimal, do standard algorithm, and then go ahead and move it back in, 67.2 centimeters. Two different ways to do it. All right, so I'm going to move on to concept development.